In this section of my presentation, I will describe the process that I followed to import the transportation data set into Hadoop and more specifically into Hive external table. You may recall from my paper that I decided to optimize for queries which were based on the input consisting of year and month. That was to improve the performance of queries in group 3. In order to achieve that, the data was partitioned first based on year, and if we drill down into, for example, year 2007, we will see the second level partition that corresponds to the month of the year. And of course, if we look at any specific month, for example, month 9, well, this is actually where the CSV file for this specific year and month is located. Needless to say, this allows Hadoop very efficiently load the data for a specific year and month without scanning through potentially hundreds or thousands of files and records. Furthermore, let's actually take a look inside one of such files. And we will use tail command just to get a small sample of that file. So you will notice that, first of all, there's a very small, there is a very limited number of columns here, and I will get to this in a moment when I describe the import process that I use, which was implemented as a Python script. But furthermore, 17 here is there's a couple of numbers. There is a 17 that is the date of the flight, and 1 is the day of the week. You may be asking yourself a question: where is the year and month? Well, that is the beauty of Hive partitioning, is that this data can be inferred from the tree structure of the directory. So in other words, Hadoop does not need, basically already knows that those fields for this specific data file are being inferred from basically from the directory structure. So this is really sort of all I needed to do in order to be able to query the data. But let me switch now to my Python script, and I will basically outline the high level functions which I needed to implement in order to partition the data and make the data available to Hadoop. So this is a high level function. I call it invoke ETL, and I will very quickly go through this. But the basic idea is very simple. We provide the source. The function takes the source, which is the mounted snapshot of the transportation data set, and basically, and more specifically, the location of the airline on time directory. Then we get all of the zip files, and basically based on the name of the zip file, we determine its final destination on the HDFS on HDFS. And the function to do this is build hierarchical path, which is given the name of the file. It determines, basically, the name of the file contains the name and the month. So we extract that data from the file, and using that information, build the destination where that file needs to be unzipped. But before we unzip the data into the final destination, we need to trim the CSV file, because only a small subset of the fields actually is required. And the indexes of those fields are defined in this Python list, and the function to strip columns is here. And again, it's a pretty straightforward process. Unfortunately, it requires reading line by line each file, and then basically this is the crux of this function, where we split the data based on the using the column as a comma as a separator, and grabbing the fields which are of an interest to us. And once we collect all the fields for all the rows, we write that as an output to the final destination. And last but not least, the final command is to using the Hadoop put command to copy the data from the local file system, where the import was taking place, into the basically Hive warehouse data directory. And that is really it. There's not really much else to this. Before I finish, I wanted to also show you something that I haven't really touched upon anywhere else in my presentation, and I want to make sure that it is covered. And that is how the data makes its way into the DynamoDB. And you will see from the other portion of my presentation where I describe the queries and them being executed. This is the part which takes the result of those queries and puts them into the Dynamo database. And this is actually done by the feature where Hive has the ability to store its external data into the DynamoDB, and this is accomplished here by this directive. So thank you so much for your attention. That is all I have.